We're going to do something a little different than what you see in the book, and we're going to work with these two networks. Ethernet 0 is on the 10110 network, and I've already got NAT inside on it, IPNAT inside. And then serial 0, which would be our interface to reach the internet. Here we're going to use 172.12.123.0 as I do often in this course. When we're done, we're going to ping 123.1 from here and make sure the address translation takes place. Because just because you see connectivity, it doesn't necessarily mean you have a translation. I'm also going to introduce you to a bonus command that you might not see on your CCENT exam, but it's an excellent lab command. It's good for troubleshooting in the field too, don't get me wrong, but it's really good for lab stuff, and I'll show you exactly what I'm talking about as soon as we get started here. We almost always begin with IPNAT, and here what we're doing is IPNAT inside, because that's what we're working with right now. And destination and source. So what we want is the source address translation. And here's where we branch off a bit. Route map, we're leaving those for future studies. But I've got a couple of options here. I can specify an access list describing local addresses, and that is used in dynamic NAT, which we're going to get to in a few minutes. What we're sticking with here obviously is static. Specify static local to global mapping. So we're going to go with static. And we've got a couple of options here, but we're sticking with local IP address because that's what we wanted to have translated. 3. And then it's going to ask inside global IP address, and that's what we want it translated to. So we're going to go with 210.115. And we have some options here. Leave those for later. You may never use these, frankly, even in the field. But we've got IPNAT inside, source, then static, because that's what we're configuring it for, static NAT, then the local address, and then the global address, the inside global address. You can already see, though, what a huge waste of addresses this would be. Because let's say you had 25 machines and this was the only option we had, static NAT. Well, if you map 25 machines to 25 different addresses and only 5 of them are going to be on the net at a time, you get 20 addresses just sitting there. So, having said that, that's really it. We've got our NAT inside and outside. I did that first, and we have our one line for our static mapping. Now I want to send a ping to 172.12.123.1 and make sure that it gets translated. But do you see a problem here, perhaps if I send a ping, just a regular old ping? The problem would be that the source address of the ping would be 172.12.123.3. We wouldn't really be testing NAT because by default the source address of the ping is the interface through which it leaves. Makes perfect sense, right? I mean, that's what you would expect it to be. So how can I, without leaving this router, send pings from the 10.0 network to 10.113? How can I make that happen? Well, what I can do is send an extended ping. And that's what we're going to jump into right now. What you want to do here is just enter ping, and then that's it. Hit enter. It's going to start prompting you for a lot of stuff. Don't hit these too fast. Do not hit these too fast, because all of a sudden you've gone past the one you want. It's like, oh crap, I got to go back. No big deal if you do. But obviously we're going to stick with protocol. It's going to ask you for the target IP address. Makes perfect sense. And repeat count. This is where it comes in handy with labs. And it can really help with troubleshooting sometimes too, but especially labs. When you go on, there will be times when you say, you know, I want to send 10,000 pings and I want to work on the config while they're going out. And you can do that. I don't really recommend it for production work. I don't see why you'd have to do that unless you're at night and you're troubleshooting. But this is a fantastic tool that lets you say, okay, I want 20,000 pings. But you just have to know how to cut them off, right? You remember how to do that? So let's go ahead and just send the 5, because we're going to take the defaults here. And we've got timeout in 2 seconds. We'll take that. Extended commands. The default is no. If you're changing the source address of the pings, which is what we're doing here, you want to say yes. That's why I said just don't tap the key 10 times and say, okay, I'm done. Now you can put in the source address or interface of the pings. And I believe if you just put in E0, it's going to yell at you because you have to go with Ethernet 0. You can't abbreviate here. But what I'm going to do is just put in the IP address. And everything else here, just take the defaults. This is where you can actually just start tapping with your pinky finger, which is what I usually do. And you just go from there. The 5 pings went out. Now let's check our translation. And there you go. 10.113 inside local to 210.115 inside global. And if you ran a debug during those pings, you would see source address 10.113. That's a really handy thing to be able to do, especially like I said, in lab environments. But that's really all there is to static NAT. That's it. And let's see. Let's go ahead and talk about dynamic NAT for a minute, and then we'll run into a lab here. Or I guess we're still talking about static NAT at first. We're still dumping on static NAT. The obvious problem here, as I mentioned a couple times, and as you saw on the live equipment, is a lack of scalability. I mean, this is just not something you're going to run in an enterprise network, right? If you have only a few hosts that need the access, it's beautiful. I've done it for small networks for one host where they just didn't want anybody else getting on the net. But most organizations today, and I'm not really saying this sarcastically, totally I guess, but in today's world of the almighty cloud, it's not really practical just to have a few hosts in your business on the net. Dynamic NAT allows a pool of inside global addresses to be created. Now, the public IP addresses are mapped to private addresses just as we saw, but on an as-needed basis. And the mapping is dropped when the communication ends. There's no permanent one-to-one mapping as we saw with static NAT. Now again, dynamic NAT requires IP NAT outside and IP NAT inside, so I'm not even going to take those off. But what I am going to do is go onto the router now, stop the recording. I'll get rid of that one command, and then we will start a dynamic NAT configuration on the next video. I'll see you there.